In this video, we are going to review how to solve two-step equations. Remember, this is a review, so you should already know how to do this. This lesson is for you to review in case you forgot. Integers will follow you for the rest of your math life career. All right, equations. To solve equations, we need to perform inverse operations to move terms to isolate the variable. All right, remember inverse is like the opposite. All right, isolate means to get it by itself, and the variable are the alphabetical letters, usually X. All right, there's a difference when you're solving one-step equations and two-step equations. When we're solving two-step equations, eventually we will end up solving a one-step equation because you're reducing the number of steps. It goes from 2 steps to 1 step. Here is just the general outline of what to do. So when you have a one-step equation, say if you have like x plus 2 equals 9. You need to identify the operation, right? There's a plus sign. Isolate the variable through inverses. So that means get rid of what's being added or subtracted first, or get rid of any multiplication or division. All right, so this is being added, so that's when we will do minus 2 on both sides. All right, save multiplication or division for last. In this case, there is no multiplication or division. It's only a one step. If it's multiplication or division, it will look like this, where there's a coefficient in front of the variable. All right, so whenever you see a coefficient in front of the variable, you know that's multiplication or division. All right, so when we're dealing with two-step equations, identify the operations. Well, this is multiplication right there. This is subtraction. Isolate the variable, so get x by itself through inverses. Get rid of what is added or subtracted first. Okay, then get rid of any multiplication or division. Save coefficients for last always. So it might be a good idea for you to circle which one the coefficient is. Coefficient is the number in front of a variable, and remember that is last. So get rid of the other one first. So add 2, and so on. Okay. So, here are some steps right here to remind us what we're doing when we're looking at these examples. Alright, so here's an example right here. I have 2x minus 4 equals 8. First, I need to look at the terms and get rid of anything being added or subtracted. Then get rid of multiplication or division. Coefficients get taken out last. So I might want to, just to remind myself, circle this so that I know, remember that's the coefficient. I want to do that one last, so get rid of the other term. That's the one that's being added or subtracted. So the inverse of negative 4 is plus 4. Whatever I do to one side, I have to do to the other. And I'm drawing this dotted line to remind me that there are two sides of the equation. It has to balance. All right, so this cancels to make 0. Then I'm left with x equals 8, 9, 10, 11, 12. Oh, sorry, 2x equals, I have to bring that whole thing down. So 2x equals negative 12. So right now I'm at this point. Now it turned into a one-step equation because there's only one step left. This is my multiplication. The inverse of multiplication is division, so I'm going to divide by 2 on both sides. 2 divided by 2 is 1. That's what I want, the value of 1x. X equals 6. Okay. All right, next example. Example number 2. Look at terms. So look at the terms. Get rid of anything being added or subtracted. Well, this is my coefficient, so I'm going to circle that to remember, to remind myself that that's going to be the last thing I'm going to get rid of. So I'm going to add 1 to both sides. I'm going to do my dotted line so I remember. That cancels out to make 0. So I get left with 3x equals 9. Then this is multiplication, so I'm going to divide by 3 on both sides. This reduces to make 1, so it's 1x equals 3. There we go. 9 divided by 3 is 3. And if you want to check your work, you can check your work by plugging this back into the equation. So 3 times 3, because we're saying x equals 3, so 3 times 3 minus 1 should equal 8. 3 times 3 is 9, minus 1 should equal 8. 9 minus 1 is 8. Yep, that's true. 8 does equal 8. So you can always check your answers for equations. Now for this video, I'm not going to check every answer, only maybe a couple here and there through substitution. This is what it's called, substitution. You should do it just to make sure your work is correct. Right? It's an easy way to check your work. All right, example 3. Okay, so I have 4x plus 10 equals 25. I'm going to circle the coefficient so I remember to do that one last. I got to get rid of this one. So minus 10 minus 10. I get 4x equals 5 minus 0 is 5. 2 minus 1 is 1. All right, then I'm going to keep going. So I'm going to divide by 4, and then this makes 1, so x equals 15 divided by 4. But I can't leave my answer like that. That's improper. So I'm going to do 4, I'm going to do 15 divided by 4. 4 goes into 15 3 times. There's 3 groups of 4. Because 4 times 4 is 16, and that's over 15. So that makes 12 and 3. So my answer is 3 and 3/4. Here's my numerator. Sorry, this is my whole number, my numerator, and my denominator. So think of it going clockwise. Big one, numerator, denominator. Here's my whole number right there, my whole number. So 3 and 3/4. Okay, so that's my answer for here. So x equals 3 and 3/4. Okay. All right, next example. Okay, so I'm going to circle my coefficient, and usually my coefficient is first because the format of equations, you usually put your variables first. So that's how it will usually be presented, but just in case it's not, know that it won't always be the first one. Okay. All right, so I'm going to add 15 to both sides. That cancels to make 0. So I'm left with 6x equals 30. Divided by 6, x equals 5. Okay, so let's just play around with what I just mentioned, that it could be, it doesn't always have to be first. So in this case, the coefficient's right here, but I will still solve it the same exact way. Okay, this is still being subtracted from that, it's a minus. So 6x equals 30, divided by 6. I'm still doing the same stuff. Okay. All right, next problem. All right, here's example 5. So I have x divided by 4 minus 2 equals 6. So I need to look at the terms, get rid of anything being added or subtracted, then get rid of multiplication or division. Coefficients get taken out last. And you can also say that, if you're dividing, that one gets taken out last too. So always get rid of what's being added or subtracted first. Okay, so here's what's being added or subtracted. In this case, it's being subtracted, so I'm going to add 2 to both sides. So x divided by 4 equals 8. Then I'm going to multiply by 4 on both sides, because this really turns into 4x divided by 4, and that turns into 1x. So that's what I want. 1x, so that turns into 1. 1x equals 32. Okay, and you can check your work by doing 32 divided by 4 minus 2 equals 6. Let's check. 32 divided by 4 is 8. Minus 2 should equal 6. 8 minus 2 is 6. 6 does equal 6. That's a true statement, so my answer is correct. Okay. If you got something like 5 minus 2 and you know you did this part correct, that means your answer, your solution was wrong. Okay. All right, let's try the next example. So I have f divided by 3 plus 2 equals 6. I'm going to minus 2 on both sides. So f divided by 3 equals 4. Then I'm going to multiply by 3 on both sides. F equals 12. Okay. And again, you can also substitute that back in. 12 divided by 3 plus 2 should equal 6. 12 divided by 3 is 4. Plus 2 should equal 6. 4 plus 2 is 6. That does equal 6. Coincidentally, it's the same as this one. Coincidentally. It doesn't mean that it will happen all the time. Okay? All right. So now for this slide, I want you to pause the video and go ahead and try these 4 problems. And then come back when you're done. Make sure you're using inverses. You have to be showing your steps. Okay, don't skip steps. Show each step like I was doing in the others. And again, I'm going kind of fast because this should be a review. Okay, all right, go ahead, press pause. Okay, let's go over number 7. So this one, I have 4x minus 3 equals 5. I need to get rid of whatever's being added or subtracted first. So I'm going to add 3 to both sides. This makes 0. So I get 4x equals 5, 6, 7, 8. Then I'm going to divide by 4, divide by 4. This simplifies to make 1x. X equals 2. Let's look at number 8. All right, this is what's being added or subtracted. This is division right here, so I need to save multiplication or division for last. So I'm going to minus 4 on both sides. D divided by 2 equals 4. Now this is division. I'm saving it for last. All right, but the inverse of division is multiplication, so I'm going to multiply by 2 on both sides. So whenever you have division, just think about multiplying by that same number on in the denominator on both sides, always. So that makes 1d equals 8. So if you think about it, 8 divided by 2 is 4. 4 plus 4 does equal 8. All right, let's go to number 9. 3g plus 3 equals 15. So I'm going to minus 3 on both sides. 3g equals 12. Then divide by 3, that turns into 1, simplifies to 1, because 3 divided by 3 is 1, and g is still there, because it's like g divided by 1. Okay, so g equals 4. Number 10, hopefully you subtracted by 3 on both sides. You should have gotten x divided by 7 equals 0. Alright, even though there's a 0, you still got to keep going because x isn't by itself, it's being divided by 7. So then you get x equals 0. Okay. There we go. And if you plug it in, 0 divided by 7, that's 0. Okay. If 0 is in the numerator, that's 0. And then plus 3, 0 plus 3 is 3, that equals 3. Okay. Sassy, right? She's a Cocker Spaniel Chihuahua mix, sporting her unicorn outfit. She has her unicorn headband and her skirt with her curly little tail. All right, come on, walk that runway, Sassy. Woo! Come on, Sassy, you can do it. You can do it. Yeah, look at her go. She's waiting right here for her snack, right before she continues. All right, she's a very, very smart dog. She knows what she wants. Very confident.
Come on.
She's saying that pepperoni is way too far away.
Let's go. Come on. Come on.
Come on, Sassy. You can do it. We believe in you. Keep going. Keep going.
Come on, Sass.
You almost made it.
Come on, Sassy.
Keep going, Sassy. Keep going, Sassy. You can do it.
Come on.
Come on, Sassy. Come on, Sassy. Think she needs some cheering on. Go, Sassy. Go, Sassy. Come on, Sassy. There's another pepperoni. Are you going to do it? Pepperoni. Are you going to do it?
Come on,
Pepperoni. Are you going to do it? She sat down. Come on, Sassy. Come on, Sassy. Let's go. Come on. Let's go.
Come on, Sassy.
Uh-oh. Sassy just wants to look pretty right here. Say hi, Sassy. Hi, Sassy. Say hi, Sassy.
Come on. I'm gonna give her a little help here. Come on.
Go, Sassy. Come on, Sassy. You can do it. Come on. Come on. All right. No dogs were hard in the making of this. Here comes Sassy again, sporting her U of A jersey. There she goes, number 1, stopping. All right, this is Sassy, 8 years old. All right, all right. Number one, U of A colors. Good job, Sassy. Look at her.
Come on. Come on.
There we go. Good job, Sassy. Yay! Good girl, Sassy. Good girl. Entering the runway is Jasper Casper Franklin Vera Cruz with his little Sunday dress and his little hat with sunglasses. Good job, Jasper. Look at Jasper. Look at Jasper go. Woo-hoo! Go, Jasper. Ooh. There he goes. You see the way you looked at me? Showing us his skills. Good job, Jasper. Good job, Jasper. Ooh. What happened? What happened? Had a little trouble with his little hat.
Sit.
Good job. Waiting for his treat. Yay! Good job. Good job, Jasper. Woo-hoo! Good job. Showing off your skills. Yeah. Okay. Coming up is Jasper Casper Franklin. All right. Here we go. Sporting the Rosie the Riveter. Look. And his little jeans. All right. Jasper's 2 years old. He wants to go back up. He wants to go back up. Come on, Jasper. You can do it. Oh.
Change his mind.
Change his mind. He wants to show you his skills of how fast he can walk the runway. Go, Jasper. Go, Jasper. Good job, Jasper. Jasper wants to go again. Go, Jasper Casper. Woo! Good job, Jasper. Yay! Good job, Jasper.
Hey, Lily.
Entering the runway is Lily.
Come on.
All right. There we go. Good job, Lily, with her sunglasses and her skirt. And her little handkerchief. What does her handkerchief say? Hangry. You're hangry? All right, you want to do it again, Lily? Come on, Lily.
Come on. Come on.
Do it again. Woo-hoo! Good job. Awesome work. Good job, Lily. All right. About to enter the runway again is Lily. All right, wearing her jogging pants. And her sweatband.
Okay, come on.
With her red shirt.
Come on. Let's go. Let's go. Show off
Come
your
on
stuff.
up. Woohoo! Look at that. She wears it well, don't you think? Look at her. Look at her.
Woo!
Good job, Lily. Good job. You're working those pants. Good job, Lily. Good job. Woo-hoo!
Want a treat?
All right, coming up the runway is Mocha Amaretto. All right. She is wearing her cowboy hat and her little dress. Cowboy hat because she was born during rodeo, right? Ooh, little mishap here. Let's fix it.
Come on. Come here. There you go. Come on.
Mocha is a toy poodle,
Come on.
miniature poodle. Here we go. Go, Mocha. Good job, Mocha. Woo-hoo! fluffy as can be. Turn around, Mocha. Good job. Good job. Look, she wants to do it again. Ooh, good job. Doing it in a dress and everything. Does not like the hat. But look. All right, here comes Mocha Amaretta. Come on, Mocha. Let's go. She's sporting her pink skirt and her pink flower headband. There she goes. Work it, Mocha. Work it. Come on. Come on. Good job.
Girl. Okay, one more time. No. Put your headband back on.
Come on, Mocha.
Come on. Let's go again. Come on.
Come on, Mocha.
Come on.
You can do it, Mocha. You can do it. Let's go. Let's go. Good job. Yeah. Say hi to camera. Her little tail. Good job, Mocha. We are going to solve two-step equations with integers. We're dealing mainly with positive numbers. All right, now we're going to be using positives and negatives and solving for the variable. Remember, look for that integer video if you're having trouble with integers so that you can use it to help you. Okay, all right, let's go ahead. All right, so I follow the same steps. This is 4x plus 3 equals negative 5. So this is what's being added or subtracted. So I'm going to minus 3 on both sides. Cancels to make 0. So I get 4x equals negative 5 minus 3. That's the same sign, add and keep. So 5 plus 3 is 8. Keep the sign, negative. Okay. Then I need to divide by 4. Divide by 4 turns into 1. So 1x equals... When I do this part, I like to do the numbers first and then think about the signs. So 8 divided by 4 is 2. And a negative divided by a positive is a negative. Okay. All right, number 2. Have negative 3g plus 3 equals 15. So I'm going to minus 3 on both sides. I get negative 3g equals 15 minus 3 is 12. Then I need to divide by negative 3 on both sides. Take the whole number. Before, if it, like over here, it was positive 4, I divided by positive 4. I didn't turn this one into a different sign. I didn't make that negative. So same thing here. Take the whole number, all right? It's negative 3, that whole integer. So this turns into 1g equals 12 divided by 3 is 4. But a positive divided by negative is a negative. All right. Next two examples. We have d divided by 2 plus 4 equals 8. So I'm going to minus 4 on both sides. So I'm left with d divided by negative 2 equals 4 times negative 2 times negative 2. That turns into just d equals negative 8. And how can you check your work with this again? Well, look, if I plug in negative 8 for d divided by negative 2 plus 4 should equal 8. 8 divided by 2 is 4. A negative divided by negative is a positive. 4 plus 4 from right there equals 8. Yes, 8 equals 8. That's true. So you can always check your answers through substitution. This is substitution when we're plugging the solution back in. That's substitution. For equations, you can always check your work. Okay, and you can always know if your answer is correct by substituting. All right, this one I'm going to add 3, I get x over 7 equals negative 3 times 7 times 7, x equals negative 21. Okay. So go ahead and try those two, and pause this when I'm done talking. Try those two, and then come back when you're done. Take your time. Remember the integer rules. Go ahead. All right, so I'm going to minus 10 on both sides. I might want to do this little dotted line to remind myself that there are two sides to the equation. All right, whatever you do to one side of the equal sign, this side you have to do to the other. That cancels to make 0. Get negative 5x equals, same sign, add and keep. So that's make negative 60. Divide by negative 5, divide by negative 5. All right. X equals, so that reduces to make 1. A negative divided by a negative is positive. What is 60 divided by 5? What does that get us? Or think about 5 times what equals 60? What does that make? All right, hopefully you said 12. And there we go. Let's try the next one. So I'm going to add 3 to both sides. Get rid of what's being added or subtracted. It's the same process as what we did before mind break. All right, I just split it up to make it easy on us so that we remember the process before having to remember about integers, the positives and negatives. Okay, so then I get divided by negative 3, negative 3. That simplifies to 1g. G equals 5. All right, go ahead and try those two and then come back. Press pause now. All right, so let's try this one. So hopefully you did minus 1, minus 1. And then that cancels. You get p over negative 11 equals 7. They're different signs, so subtract. Take the sign of the further number. 8 is further away from 0 than negative 1. So it'll be positive 7. Then times negative 11, because I'm following the same steps, equals negative 77. Okay, and I'm going to change markers because that looks kind of light. All right, maybe I should retrace this one just in case. So it's minus 1, cancel. P over negative 11 equals 7 times negative 11, because I multiply by negative 11, cancel. P equals negative 77. Okay. All right, over here I'm going to add 12 to both sides. I get V over 2 equals, they're different signs, so I'm going to subtract and take the sign of the further number. Negative 34 is further away from 0 than 12, so negative 12. Oops, that should be a 2, so negative 22. Okay, and then I'm going to multiply by 2 to get rid of this denominator. So V equals negative 44. Okay. And that is all for your two-step equation review. If you were having trouble with what came after mind break, the integers, you should review your integers and look for the video of integers to remind yourself how to solve for the integers. Remember, when you're adding or subtracting, you use the integer song. If you are multiplying or dividing, you use pizza face or the tic-tac-toe. Okay, that can really help you. All right, see you later.